Imagine a place where gravity is so powerful that it can warp space itself, bending the fabric of time and space. A place where nothing, not even light, can escape. This is the concept of a black hole, one of the most fascinating, mysterious, and mind-bending phenomena in the cosmos. For centuries, we thought that nothing could ever escape the reach of gravity. But black holes challenge this idea. They represent a boundary, a point where the usual laws of physics seem to break down completely. But could such an extraordinary entity really exist in our own galaxy, the Milky Way? We've heard the theories, we've observed the signals, but can we really say with certainty that a black hole exists in the heart of our galaxy? What does it mean for our understanding of space, time, and gravity if the answer is yes? Today, we embark on a journey to explore black holes, their role in the universe, and most intriguingly, their existence right here, in our own galactic backyard. At its core, a black hole is the end stage of a star's life. When a massive star exhausts its nuclear fuel, it can no longer sustain itself against the crushing pull of its own gravity. In an instant, the star's core collapses inward and the outer layers implode, triggering a cataclysmic event known as a supernova. If the remnant core is massive enough, it will continue collapsing, eventually forming a singularity, a point of infinite density surrounded by a region known as the event horizon. The event horizon is the critical boundary of a black hole, beyond which not even light can escape. Once an object crosses this threshold, it is lost to the black hole's powerful gravitational pull. But what if we could actually pass through the event horizon without being torn apart? What mysteries would we encounter inside? Could the inside of a black hole hold the key to understanding the fundamental laws of the universe? In theory, black holes represent a paradox. On one hand, they seem to violate the known laws of physics, but on the other, they provide us with a unique window into the unknown, where time and space are completely warped. Perhaps understanding them could lead us to unlock a deeper understanding of the universe itself. For years, black holes were considered to be purely theoretical, mathematical curiosities that could only be described by equations. But in recent decades, astronomers have gathered compelling evidence to show that black holes are real, tangible objects. And even more astonishing, some of these black holes exist right here in the Milky Way. One of the most direct pieces of evidence comes from observing the motion of stars around invisible objects. When stars orbit something that can't be seen, but whose gravitational influence is apparent, astronomers infer the presence of a massive, compact object, most likely a black hole. Through these observations, we've uncovered startling discoveries. Some stars orbit what appears to be an unseen mass, accelerating to incredible speeds as they whip around an invisible point. What if these stars are being held in orbit by the immense gravity of a black hole, a force so strong that it defies our understanding of gravity itself? Indeed, astronomers have found compelling evidence for the existence of Sagittarius A*, a supermassive black hole at the center of our galaxy. It has a mass 4 million times that of the Sun, and its gravitational influence is so powerful that it affects the orbits of stars in its vicinity. Even though we cannot directly observe the black hole itself, we can measure its effect on nearby stars, providing us with clear, unambiguous evidence of its existence. While we can't see black holes directly, their presence can be detected by the impact they have on their surroundings. When a black hole interacts with nearby matter, be it gas, dust, or even whole stars, it causes a violent reaction. Matter that gets too close to a black hole is torn apart by its immense gravitational forces, creating what is known as an accretion disk. As this matter spirals toward the black hole, it heats up to incredibly high temperatures, emitting powerful X-rays and radiation. What if we could use this radiation as a cosmic fingerprint, tracing the path of black holes across the universe, piecing together the puzzle of their existence? Astronomers use specialized instruments, such as the Chandra X-ray Observatory and the Event Horizon Telescope, to detect this radiation. These observatories allow us to observe the behavior of matter near a black hole, giving us a clearer picture of its size, mass, and effects on its surroundings. Additionally, the detection of gravitational waves, ripples in space-time caused by massive objects like colliding black holes, has provided another piece of evidence. In 2015, the first detection of gravitational waves confirmed the existence of black holes merging, offering a direct confirmation of their presence in the universe. Now, let's focus on the heart of our own galaxy, the Milky Way. Could there be a supermassive black hole lurking at its core? The answer, based on the mounting evidence, is a resounding yes. The supermassive black hole, known as Sagittarius A*, resides at the center of our galaxy. While we cannot directly observe it, the motion of nearby stars reveals its presence. By tracking the orbits of these stars, scientists have been able to calculate the mass of the black hole with astounding precision. At roughly 4 million times the mass of our Sun, Sagittarius A* is an incredibly massive object, and yet it occupies only a tiny fraction of the space at the center of our galaxy. It is a cosmic giant, with a gravitational pull strong enough to influence the motion of stars and gas clouds across the galactic center. But the question remains, what if this supermassive black hole plays a central role in the evolution of our galaxy? Some scientists believe that black holes are not just passive observers of the cosmos. Instead, they might actively shape the formation of galaxies and stars. The energy released by matter falling into a black hole, known as accretion energy, could regulate star formation in the galaxy, preventing the excessive growth of stars and controlling the distribution of matter. This process could have a profound impact on the structure and behavior of galaxies across the universe. While we have observed black holes in our own galaxy, astronomers believe that they may be more common than we realize. Supermassive black holes are thought to exist at the centers of most galaxies, including distant galaxies far beyond our own. But could there be even more exotic types of black holes? We know that black holes can range in size from stellar mass black holes, formed from collapsing stars, to the supermassive black holes at the centers of galaxies. But some theories suggest that even primordial black holes, tiny black holes formed in the early universe, could exist, potentially hiding in the dark recesses of space. What if black holes are not just isolated anomalies, but essential drivers of cosmic evolution, shaping the galaxies, stars, and matter around them? The answer is not only yes, but it's also a resounding and it's right here, at the heart of our galaxy. The supermassive black hole, Sagittarius A*, is a real, observable object that plays a crucial role in the structure of the Milky Way. And as we continue to study black holes, using increasingly sophisticated technology, our understanding of them will only deepen. But the journey of discovery doesn't end with the black hole at the center of our galaxy. Across the universe, black holes are waiting to be studied, their mysterious and powerful presence offering us new insights into the nature of space, time, and the fundamental forces of the cosmos.